All right, so now we're at the second law of thermodynamics. In a spontaneous process, entropy of the universe increases. So delta S, remember, whenever we have delta, that means the change in. So delta S of the universe equals delta S of the system plus delta S of the surroundings. So we have to define the system and the surroundings. We did this before when we were just looking at QSMAT problems. And the system is what we care about. And the surroundings is everything else. So remember before, if we had a reaction happening in the beaker and that was the system, then literally the surroundings are everything outside of that. All right, when delta S of the universe is positive, we have a spontaneous process. And temperature affects spontaneity. So if we look at this one, liquid water going to gaseous water, well, we know that just liquid to gas, we're going to have an increase in entropy. So the delta S of our system is positive. We increase our volume because 1 mole of liquid water takes up much less volume than 1 mole of gaseous water. So if the system is positive, then the surroundings are negative. So which one dominates? We have to know about the temperature. So the lower the temperature, the bigger impact the heat has. Heat flow is our change in enthalpy, which we dealt with before in a previous chapter, our delta H. When delta H is positive, heat's going into the system. Delta H negative, heat's going out of the system. So we have our equation there. Delta S of the surroundings is negative delta H over T, and we have to keep our temperature in Kelvin. So let's look at this. We have an equation. And let's just look at this. We have 0 moles of gas on both sides. So we can't use that for predictions. All right, so our delta S of our surroundings is going to be negative, because there's a negative in the equation, negative 125 kilojoules over 298 Kelvin, because we have to do our 25 plus 273 to get to Kelvin. So we're going to have a positive value. We can tell that already. So there we go. So we have 125. Whoa, really need to get out of that math thing from solving equilibrium problems. All right, now let's try this again. 125 divided by 298. Just looking at that, we know it's going to be a half-ish. So we have 0.419. And our units on this are kilojoules per Kelvin. If instead we want it in joules, 1,000 joules is 1 kilojoule, so that would be 419 joules per Kelvin.